In this video, I am going to be showing you the top 3 methods for safeguarding your N8N webhooks. Now, getting straight into it. The first method we're going to be looking at is pretty typical. It is pretty much an API token or a secret key, right? Now, if we go over here to the webhook, I have a basic mock data set up to demonstrate or to replicate a webhook call. If you don't know, a webhook is pretty much whenever you attempt to trigger a workflow or a backend system using a button, a chatbot, whatever. Like for example, if I hit this button right here and that triggers a email to be sent to me, this is pretty much a webhook call, right? So here we're going to pretend that we got data from some other endpoint, website, platform, whatever, with this mock data. Now, from there, we have a switch node set up to determine if it's a secret key, API key, etc. If it's a HMAC or a authentication. Now, I'll get into these two later when it's time, but for right now, we're gonna be focusing on the secret. Now, if we go ahead and run this part right here, obviously, the authentication mode is set to secret. And the secret key in this example is going to be demo key 123. Now, the pros and cons of a API key, a secret key, is for one, it's very easy to set up. If you have a system like this right here, let's just say run this, right? For example, you can have a basic security system set up where, okay, if the header API key is set to demo key 123, which is the key we have going over here, you can go ahead and run the system, have it respond, go through the workflows, do everything it needs to do. However, if we were to, let's just say, change this to 1, 2, 3, 4, or 1, 2, 1, 2, boom, it doesn't work. So that's pretty much how API key works. It's basically a key. Does it fit in or does it not fit in? That's the whole purpose of it. Now, it's very easy to set up, very simple. It's not a big headache. It's very easy to install in almost every system. Doesn't matter if it's N8N, Make.com, Vibe coding, whatever. It's very easy. But the negatives to it is it's very easy to steal and to use against you. For example, if we come over here and let's just say we're tracking everything that comes in through the webhook call, right? Or actually, matter of fact, let's change this back. Go ahead and run this. Boom. And now we do this right here. Respond to webhook. Okay. So the whole workflow went through. It was completed. And now the webhook responded back, right? Meaning it responded back to the system. So let's say we have a web app set up that's triggering this entire workflow. Once it responds, it's sending our response, which is this right here, back to the web app. And now let's just say there was a bad actor who was watching that little pathway between this and the web app that we have set up. If they can go in here and see, okay, the API key is set to 1, 2, 3, they can easily copy that and then trigger this workflow and this backend whenever they want. And that's a big negative. And another issue with that is, let's just say, let's go back to the webhook really quick. We went in here and we changed this around to, let's say, the body. Let's do this. Let's go ahead and add another little thing here really quick. Let's just say message. Message. Oh, what did I just do? Oh, my fault, y'all. Let's say message is equal to test workflow. Boom, boom. Okay, so if we add this message in right here, right? Now let's just pretend this was the message that we needed to send back to the web app. So when we run this again, let's go over here, boom, boom, boom. Boom, it sends it back. However, what if we had a open AI node, just for example, that was connected to our Airtable, boom. It was connected to our, now let's pretend we also had to connect to whatever, a vector database, right? Nope. Now this is where we have all of our client information, credit card information, everything. And if we had a code in here that said using your DB node, give me the info, right? Whatever. Now, when we run this again, I'm not going to do it right now, but if we ran this again, this OpenAI node is going to give us the information that's stored in here. It's going to give everything, maybe a little bit, depending on the prompt injection. Oh, by the way, this would be called a prompt injection, right? Whenever you have malicious prompting inside of your original prompt from a bad actor designed to steal information from you, is called prompt injection. So in this situation right here, because for one, they have the API key and they know that a AI model is involved somewhere in here, it's going to pretty much give you or give the bad actor what's ever inside the database, which can be client information, your information, private, whatever, right? Secret information you don't want getting out. And that's the issue with API keys, is that they're too static. They don't change, and it's very easy to get them. And when you get them, you can do whatever you want in the back end if the bad actor has a little bit of information on what's really going on. So for that reason, I would have to rank and for that reason, I would rank API keys or secrets as the least secure method when it comes to protecting your N8N automations, make.com, vibe code, whatever. Now, the second method for securing your automations is going to be called HMAC, and that stands for hash-based message authentication code. Now, pretty much what it is you're taking a signature similar to an API key. Actually, let me just go ahead and get this demo payload over here. Boom. Boom, pull it over. Edits. Boom, go ahead, paste that in. Go ahead, paste that in. Boom, there we go. Okay, so now, if you're looking here, it has three different parts, right? It has the signature. Now, the timestamp for this is going to be basically a window of time that a specific time frame is connected to a specific nonce. So a nonce is pretty much a one-time, or think of it as like a one-time ID, right? So this demo nonce 1 is only going to work once with this specific time frame or window of time. So the signature is just for mock data, and then replay is just again just mock data, right? But in a real situation, when we run this, so if we go ahead, save this, run this, boom, okay. Go over here, we get boom, the mode is HMAC, it's true, and it'll return whatever comes through. Now, the reason why HMAC, honestly, is one of the most secure options is because, for one, it doesn't have a API key function like a basic secret does. Meaning, even if you have the nonce, you also need the exact time frame that it's equipped to. Hopefully that makes sense. So you can't have the key without having the correct lock. And these two is gonna, that's a bad explanation. Okay, so basically, to get the full key, you need both parts. You can't have the grooves of the key without the handle of it. But only one handle goes with one groove, if that makes sense. So, for example, right now, this is code to verify the MAC. But again, this is mock data. Realistically, if this was an actual webhook call that was set up for HMAC, if you change anything, right? So let's pretend we already ran this right here. So this key, this key has already been used. So the timestamp and the nonce has already been used once. Meaning, if a bad actor, a hacker, was able to get a hold of this right here, they can't necessarily run this again because this combination has already been used. Now, if this body was changed, so actually let me back up. So the reason why HMAC is so good is because it takes the timestamp, the nonce, and the body message, and it pretty much creates a secret code for all of that at once. So a secret code, let me just show you right now. So let's pretend the message was, or the timestamp is, boom, whatever, nonce message, right? So this is the hash right here, and it'll save the hash to something like, so this right here would be equal to hash value, right? Boom, that's right there. And then the everything else would be this. So let me just do like this so you can actually see it clearly what's going on here. So change this to this. Boom. Okay. Now, if a hacker, let's just say, retook the same payload, or if they somehow got the message, I'll just copy and paste this so I can come back to it. Discard. Let's just say a hacker somehow got the webhook call right between here to attempt to inject it with some type of malicious code or message, whatever. When it gets to the verification step, the backend is going to know that, go back here and edit it, this hash has been changed because the first request message, let's just say they took the message, whatever name, and we changed it to, instead of first request, it's second request, right? So now when the backend, when the code runs, when the system runs, whenever or whatever, tries to turn this back into a hash to replicate this, is going to see, wait a second, the original hash is not the same thing that's here. So this message was changed, meaning, go ahead and show you what, let's just, for example, change this back. Boom, change it back. And then we're going to change this to true. Again, this is just mock data. So the code I have set up right now is meant to demonstrate what it would look like in real life. But this isn't an actual HMAC situation. But let's see, we run this again. Boom. So instead of going to the webhook call, it's going to go through here and it's false. A replay attack detected. Now, a replay attack, I don't remember if I said so in the API key section or pathway, but basically it's an attack where you repeat the exact same webhook call, for example, but you instead add in malicious code, or you just keep running that same webhook call over and over again to run up the cost or to break the system, a DDoS attack, etc. Now, when the code node detected that the hash was changed, or the hash that it took, when this code node saw that the hash that it originally was, given can't be replicated with the data that's being given through the webhook call, it's going to know that it was changed and give you this error right here, meaning a replay attack was detected. It's going to shut down the whole system. Nothing here is going to be ran. Your OpenAI nodes will never get a chance to run. Nothing's going to happen. And for that reason, I believe that HMAC is one of the most secure options really to use for a backend. It's not always needed or necessary, but it is definitely one of the better options out there when it comes to security. Now, if you're building anything like something on Shopify or something with Stripe, PayPal, whatever, I highly recommend you have an HMAC security method in place. Now, the cons to it is, for one, it does take a minute to set up. I'm not going to lie. It's not as easy as just generating an API key and then just, waiting for that one key to work over and over again. It's more complex than that. There does need to be a working verification system as well. You need to be able to store the once and the time frames in you need to be able to store the nonce and a timestamp in a credible way, as well as having a system that can properly hash everything together. Because if your logic to creating the hashes, which is basically a password that's combined of different phrases and moments in time, in this example right here, is just the timestamp, the nonce, and the message combined to create a secret code. Basically what that is. If you don't have a system that can easily replicate or read it properly, then it's not going to work. Also, another big thing is, even though the secret, again, you can have this be replicated over and over again, but once this secret does get out, then the whole system becomes compromised, because it wouldn't be that hard to brute force your way through a timestamp. There's only so many times it can be, right? In a span of 24 hours, or depending on the timestamp, whatever you have set up as, there's only so many options for this. Compared to a secret, that can be anything. But if they get their hands on this, it's going to be way easier to get in if they have their, something like this as well. So for that reason, actually, they wouldn't even need the message anymore, because then they can just create their own. once you have the nonce, you can create your own system of getting in and out. And the reason for that is because really the replay attacks wouldn't work because you would need the hash, you would need the nonce, you would need the timestamp, all of that. But if they have this, once they have the nonce, which is basically the secret key, they don't need the timestamp or the exact message anymore to recreate that hash, because now they can just send their own brand new webhook call directly in because they have this right here. So again, it's super secure, super easy to set up. But overall, the HMAC is probably one of the most secure options for securing your N8N backends. And last but not least, we have OAuth, which is pretty much the basic system that most endpoints use. Especially if you're dealing with something like N8N, a lot of webhooks and headers use OAuth. Now, basically, it'll be a situation where, let me just go in here, change the mock data. Let me just go in here and change the mock data around. There we go. So whenever you see something like authorization bearer, which is basically like a token, whatever, whenever you see a situation like authorization and bearer and then the token, that's pretty much going to be a OAuth situation. Now, this is great because it not only confirms the identity, right? So you can't get into the system without having the correct authorization, aka the key. So even if you have the knowledge of the endpoint, they can't get in without having this part right here attached to the webhook call. Another benefit is that the authorization or the OAuth has an expiration date for the keys. So let's just say you have a brand new key being generated every other hour, for example. If a hacker gets this, it's only going to work for a certain amount of time. So if they get this whole webhook call right here, this won't work if it's past an hour. Or you can change it to a month, whatever. It depends on how you set the key up in your settings. Now, this is pretty much a standard for integrations. Like, if you go to a good amount of endpoints, let's just say, I think Airtable uses it. Airtable is an API key, but a whole bunch of APIs use that type of authentication method right there. Now, if we go ahead and run this, boom. Go through here, check if the OAuth is verified in this code. We check if the OAuth is valid. Here with this mock data code all this is mock data. It will look different in real life situations. If you want to see me do any of those or any of these methods in real life with an actual example, comment down below, let me know. As well as if you need help setting any of this up for your business, if you want to set up an HMAC system because right now you're using a secret, you don't really feel secure with that anymore, you want to get an HMAC or OAuth system going, let me know. We can definitely sit down and talk about that and come up with a solution to make it happen for you and your business. As time goes on, I highly recommend you invest more time in security and not just the latest AI technology, because the better the technology with no gatekeeping in place, the easier it is for a bad actor, a hacker, to just come in and take everything you have going on. So I highly recommend, if you're investing in $5,000 for automation, you better be investing at least 25 to 30% of that same amount into somehow securing that whole system. Because if you have a whole automation system going on that takes care of your clients' payment history, credit card information, social security card, whatever, you're putting all that in one place. And if that one place isn't secure, you're putting all of that into one place. And if that one place isn't secure, you're just setting your clients up to be hunted down. So again, if you want help with that, click the link down below. We can sit down for about 15-20 minutes and see if it would make sense for us to work together to come up with a solution for you and your business. Now, back to the video. Come in here. True. Yes. So, because the header of the Yes. So because the token is in fact equal to this right here, it's going to give us true. But if we were to change this, let's just say we tried to break in, we're a bad actor, we're a hacker, and we change this key to boom, save it, boom, come back to here, ran this, boom. automatically the system is going to detect, no, this is not a valid token. You are a bad actor. You do not belong in here. Stay out. Boom, invalid token. And again, you've probably seen this a good amount of times if you played around with N8N or any automation system. You've seen this right here. So that's that right there. Now again, if I had to rank all these in order, the best would be HMAC because it's just the most secure option. But again, it's harder to set up. It's not as easy to use as a secret or a bearer token or OAuth. The second most secure would be OAuth, of course. Very simple, very easily, it's pretty easy to install and set up. And at least it's just a secret because once you get this, you can get access to the entire system. But in terms of recommendation, depending on what you got going on, if you have anything with like credit card information and banking or anything like that, like super sensitive data, I recommend going with HMAC. Otherwise, OAuth is probably the best option for you. And secret, I just wouldn't recommend having a system where you only use this. Definitely use this, an OAuth system, especially if you're just in production. Definitely, if you're going to production, use OAuth. If you're just testing around, you want a way to protect your information, but you're not using it in production just yet, then secret's a pretty good way to get security and speed for testing everything out. So again, if you want to work together to set up a system to secure you and your business, I highly recommend you click the link down below, schedule a free call. Again, we can sit down and talk about if it makes sense for us to work together to secure you and your business for you, your client's sake, for everyone. So again, if you enjoyed the video, make sure you like, comment, and subscribe. I appreciate you.